This video, we're going to actually work a sample chi-square problem. Here you have a pea plant that's being crossed with another pea plant. Yellow seeds are dominant over green seeds in an experimental cross. Two heterozygous plants are crossed. And these are the results. We get a total of 6,024 seeds. Out of that, 4,400 are yellow, 1,624 are green. So you ask yourself, what is the expected ratio for this cross? So in this cross, we crossed big A little a times big A little a. So if we do that cross, what do we expect? Big A little a, cross. So we expect out of these four possible offspring, 3 of them are going to be the dominant phenotype. 1 out of 4 will be the recessive green phenotype. Okay? As we know, 3 out of 4 is 75%, 1 out of 4 is 25%. So now that we have the expected ratio, we apply that ratio to the actual offspring we got. So expected values, yellow, we said we expect 75%. Well, what is 75% of 6024? 6024. And how did I get that? I got that by adding 4,400 with 1624. Plus 1624 is 4,400 plus 1624. That gives us 6,024 offspring. So if 75% of that is 4,518, and out of 6024, how much is 25%? 1506. So in a perfect, absolute perfect world, we would expect 4,518 to be yellow, 1,506 to be green. Now, let's do chi-square, calculate chi-square, and see how good our data is. Observed minus expected squared divided by expected. So, we observed 4,400 yellow. We expected 4,518 squared divided by 4,518 plus we observed 1,624 green peas. We expected 1,506 squared divided by 1,506. Okay, so plug in some math. 400 minus equals square that divided by 4518. That gives me a 3.08. I'm going to go ahead and round that to 3.082. So this is 3.082 plus this value here, 1624 minus 1506 equals, square that, divided by 1506. Well, holy smacks. With a number like 9.245, so 9.246. And 9.246 plus 3.082. Okay. I'm adding those two values. I get 12.328. So my chi-square value is 12.328. But wait, I am not finished. I have to move on. I'm done with the calculator though. How many degrees of freedom? Well, with degrees of freedom, we had 2 choices. The peas could be yellow, the peas could be green. That's 2 choices. Minus 1 is 1. So there's 1 degree of freedom. Now we're going to use our critical values table. have our chi-square value of 12.328. Here's our critical values table. And we're looking for 12, this 1 degree of freedom. We use this first row because we have 1 degree of freedom. We're looking for 12. Oh my gosh. As big as it goes is 7. So, wow, what does that tell us? That tells us that our p-value is less than 0.005. So, our p-value is less than, let's bring it, or you could say, yeah, either way. So, one more time, we're looking for 12.328. That's way over here on the right side of the table, so it's beyond 0.005, so it's less than that. Our acceptable mark here is here. So, is the deviation of data from the expected values within acceptable limits? No. And if we had constructed a null hypothesis, we would have rejected the null hypothesis. And that is how you do a very simple chi-square